My name is John Devins. I am the VP of Customer Success at a company called Cavass Analytics. And I prepared a short presentation. And what I want to do is introduce you to Canvas, our software platform, and then talk a little bit about how we are applying AI and machine learning in the industrial area, industrial companies. So just a little bit of the background on us, and I got to go a little bit more into the platform, but we focus mostly on industrial companies, and we're using machine learning and AI and machine learning to optimize either processes or improve asset reliability in industrial companies. We are about a 4-year-old company, and we have some interesting investors. We have Google as a lead investor. They invested in us about a year and a half ago. And then this is hot off the press. No one else knows this other than our staff. But tomorrow morning, we are going to be announcing a round of funding, a Series A, and the lead investor was Yamaha Motors, and as well as some other venture capital companies. So Yamaha Motors is, between Google and Yamaha, those are two pretty good investors. I think a testament to the kinds of things that we're doing at Canvas. We focus, our main focus is on large industrial companies. So you'll see a selection of those to the bottom right there. We do work internationally, and I'm going to talk a little bit about our software platform. So I know this is a lot of words on a page, but I'll give you the story. The story is that we started about 4.5 years ago, and we were providing AI and machine learning mostly as a service. So we would go out to customers, industrial companies, who would say, you should really be using AI and machine learning because it's the future. And, we'd give them all sort of the good reasons, and they would buy into that idea, and they would sign up with us, and we'd do a proof of concept. And then we would then take that proof of concept, would prove some value, and we would turn that into an ongoing contract. So what's commonly known as ARR, or annual recurring revenue. And while we're doing this, while we're delivering these projects, we're building software to help us do things that deliver these projects faster and more efficiently. And we got to the point about a year and a half ago where we realized that we'd actually build a fairly decent software platform. And we really should be selling the software platform as opposed to trying to deliver AI services or machine learning services. And the main reason was that we found that in the industrial space, it was really hard to scale that. Because what we were doing when we were delivering AI as a service is we were having to learn a lot about our customers' businesses. So we were having to learn how to make steel. We were learning how to make pasta, how to make a lot of different products and services, or a lot of different products. And we realized that was going to be really hard to scale that because we'd have to find experts in all these businesses. And so we thought, actually, a better business model would be to sell the software as a service. So a little bit about the platform. It's cloud-based, based on Microsoft Azure technology. We focus on industrial companies and the data that's unique to them. So what's happening in the industrial world is there's a lot of companies who are putting sensors onto their equipment, and they're gathering a lot of data. And what they've done is they're gathering all the data, but they're not necessarily keeping and analyzing it. What they're mostly doing is they're mostly looking to see what's happening at the present moment. So they're looking to see whether the temperature has gone up or the vibration on a particular machine. But they haven't in the past anyways, they haven't taken that data and then kept it and then done a lot of analysis to figure out if they may be able to prevent some of those, equipment failures or optimize the process that they're undertaking. So the software platform that we've developed is really geared to companies who want to deploy AI and ML at scale. And what we always say to our customers is that there's lots of opportunities within an industrial company to deploy AI and machine learning. But the question is, how do you do that? How do you do that cost effectively? So we created a tool, software platform that's dedicated or directed to operational technology people. So these are people in the company, in companies who are process engineers, or they're maintenance managers, or they are in charge of, or they have responsibility for continuous improvement. And those folks, when they are faced with the challenge of doing their job, they have some tools available to them, but what they don't have, or they haven't had in the past, is they haven't had a single platform that would allow them to deploy AI and machine learning right from the stage of visualization all the way through to production. And when we say production, what we mean by that is that the steps our customers, their journey is they typically they'll start to gather data, collect it, keep it, do some an analysis on it, do some visualization on it. Then they'll build a model, a rudimentary model. And then once they have proven that model is successful and it works, it's predicting what they want it to predict. They want to put that into production, meaning they want to live stream data into that model, and they want to get some kind of prediction coming out of it. And what they do with those predictions is they send those predictions to operators, and they tell the operators how to tweak and tune the machines. So what we've created here is something that really allows the operational technology people the opportunity to identify opportunities quickly and build models, or almost as important is actually to fail fast. So if they get into a situation where they've collected a lot of data, that, they may have an idea, I think we should do this with machine learning and AI, they can quickly grab the data, they can run it through the platform and decide whether they've got an opportunity or not. If they've got an opportunity, great, deploy it. If it's not an opportunity because it doesn't work for whatever reason, then they can move on. And in the platform, what we've done is we've built a library of algorithms for common industrial problems, that really data science problems or opportunities. Because in the past, and what we're really competing against, they're really competing with consultants that come into a company. They may work for a large consulting firm, and what they do is they come in and they have to learn all about the customer's business, which takes a lot of time. Then they have to do some experimenting with some models, and it becomes very it becomes very expensive very quickly, especially if you want to do it at scale. If there's a lot of opportunities within a company, the cost of bringing in consulting firms to do data science can get pretty expensive. So we've created a software platform that allows customers to take the data. They first start with an idea. I want to be able to predict when this machine is going to fail. They take the data that's related to that particular problem. They run it through our software platform, and if they're looking for a failure, there's an application that will tell them, or I should say, there's an application that has a library of algorithms that are best suited for coming up with models to predict that, and they can very quickly to see whether they've got that there's half decent results. And if there's half decent results, then it may be a process of iteration to perfect that model or at least get it better. And we have the ability in the platform to use our standard models with these standard algorithms, or there is the ability to bring your own custom models and host them in the platform. And the key thing for a lot of customers is that what this does is leverage the investment in their productivity tools. So a lot of our customers, or some of our customers, are actually collecting the data already, and they're using it to visualize what is happening with their machines now. The temperature's going up, the vibration's going up or down. But what they're not able to do currently with until they use machine learning and AI is predict what's going to happen next. And that's where the real value comes into these productivity tools like data historians or data lakes, is taking that data and be able to make a prediction so that the customer can actually get some value out of all this data they're collecting and the investments they've made in these productivity tools. So as I mentioned, we are focused on process engineers because they're the process experts. We've taken a software platform that's pretty sophisticated. We put a very easy to use user interface on it so that they can use this very powerful tool to visualize their solutions, visualize their data, do some analysis, and then eventually develop some rudimentary models, which they can determine whether there's value in those, whether there is value in that or not. And they can develop these solutions on their own, and so they can do it quicker, right? So it's saving them time. It's also giving them control, and they don't have to rely on a consultant to build and retrain and maintain the models that they want to put into production. Pictorially, the platform looks something like this. We've got data sources here. These are data historians or data coming from typically machines, industrial machines. And these are the various different, we call them pipelines or templates, which are a library of algorithms that are best suited to forecasting, anomaly detection, defect part prediction, failure prediction, simulation, and optimization. So the customer looks at these various different things they want to forecast. They decide, let's say, okay, I want to do some forecasting. They'll take the data, they'll run it through the forecasting pipeline, and then they will get a result out this side, which they then send to an operator to say, okay, this looks like this is going to happen, so you want to take this kind of action. In the middle, we have the ability to do some connecting with various data sources, contextualize the data so that we know that we may have to bias the data in certain ways, so that gives the idea, so it gives us models more after what, or they're giving results which we want them to give. And then once they've developed those models, we want to deploy and monitor them. This is a very important part of the platform because it's great when you build a model using offline or historical data. But if you want to use it live and in production, you have to have a platform that hosts that'll send these predictions. So first of all, it'll bring the data in on an ongoing basis or a streaming basis, and then it will send predictions out on an ongoing basis to operators so they can take some action. Okay, I talk a little bit about, so what I'm going to do now is I'm just going to go into an example where we've deployed machine learning in the steel industry. And we've deployed it in many different industries, but this is just an example of how we would deploy it in one industry. So the first thing we look at with a steel company is we say, okay, here's the three main things that we can do. One of them is optimize the assets they have. These are typically machines, by doing stuff like, increasing the reliability or reducing the downtime, optimizing the processes. So reducing the raw materials that go into a particular process or a manufacturing process, for example, or it could help improve the quality or reduce the waste. And the third thing, which is we probably undersell it, but it's actually very important, and that's capturing institutional knowledge. And I'll give you an example of that when I get down to some of the examples I'm going to show you. The thing that and this is a business discussion, not necessarily a technical discussion, but this is a lot of what our data scientists do and our salespeople as well. Is when they talk to a customer, they look at how do we optimize assets or how do we optimize processes. So we call this presentation between the lines because essentially when a machine, this is an example of a machine here, when it's operating between these lines, everything is good, it's fine. But what happens is the machines start to go, they go out of specification, and so you'll find that things are starting to happen here, and we're plotting them. And when they're happening here, the machine is probably degrading. And this could be, example, it could be a wind turbine where, it's the bearing is starting to fail, or it could be a welding application where they're welding auto parts and the welds are becoming defective. And when they get outside these lines, then the problem is, well, it looks like what's happening is it's set of specifications, right? So what the company would then do is the company would say, okay, what you need to do is you need to go in and you need to do some preventative maintenance, because when these red dots start to get significant red dots, when there's more red dots than green dots, it means they're starting to lose money. That means they need to probably send the maintenance engineer out to fix this machine because it's out of specification. Another example I'll give you, and this is as common in steel manufacturing as it is in making pasta. And so typically what happens is that a company is using their operators and they're turning dials and they're trying to keep a process in between two lines. If they can't keep it in between two lines, and they start to get outside of these two purple lines, they're actually starting to lose money. And typically what would happen if I use a steel for an example is that if they're not using AI or machine learning, what's happening is they're sampling at this particular point, and they're sampling for things like they want to make sure the content of steel in their product is at a certain level. So this could represent the amount of silicon that's present in steel. And what they're trying to do is they're trying to control it. They're trying to keep it between these two lines, between this line and this line. So what they do to do that is they go and they do a sample. A guy runs out to the steel mill, he scoops up a little bit of steel. They bring it back to the lab and they do a test. And they realize at this point, everything looks good. We're still between those lines. But when they sample here, what happens is they realize, oops, there's too much silicon in the steel. We need to turn the amount of energy that's being applied to this process down. But it takes a while for that to happen. It takes a couple of hours. Oops, sorry. Meanwhile, what's happening is they're actually losing money because they're applying more energy than they actually need to apply to that particular process. So what we're using AI and machine learning to do is do interim sampling using data. And actually, we're not doing sampling. We're just using historical data to actually predict where the level of silicon is going to be in the steel in, let's say, an hour or 2 hours. And that allows the operator, if they can, or when they watch this sampling process, you're using data to make decisions. They can actually now start to turn the dials and keep the amount of silicon in the steel in a tighter range, which reduces the amount of energy in the process, but also allows them to which means that they're spending less money on energy, but also improves the quality of the product because now it's more consistent. If you get product made up here or down here, the quality degrades and they have to sell it for a lower price. So typically when we go into a customer, like a steel customer as an example, this represents their factory. And all these red dots are opportunities where we think we can apply machine learning. Now, it's not always the case. I mean, some companies you can't, but if we start here, this is sort of the main process or the beginning process. This thing's called a blast furnace. And what they do is they dump a lot of materials in here, raw materials, then they heat this thing up to an enormous amount of very high temperature. And then out of it comes the molten metal, and they put that into various different forms. Here they're pouring it into casters and they're making rolls of steel. In this particular area, there is a lot of data, and the raw materials are very expensive. So the opportunity here is just to optimize the raw materials that go into the blast furnace. Closer to this end of the process, you're impacting the quality of the product, or you're improving the customer experience because you're producing less defects. So down here, I'm going to show these two examples in a minute. When you get down into this area, the cost saving, the data may not be as plentiful. It's a little bit more difficult to get data out of these machines because you're not putting raw materials in. But what you're doing is you're improving the quality, the end quality that's going out to the customer, and or if you have less defects, you can produce the products faster, meaning that there's not a delay in when they ship the product and they don't have to do reworks and things like that. So this is kind of when we go into a steel company, we kind of look here, we talk to customers, we try and get an understanding of their business, where they think the opportunities are, where they're having problems. Okay, so here's a couple of areas. We look at steel as an example. We're looking at blast furnaces or arc furnaces. These are just two different ways that steel gets made, and we look for things like can we optimize the energy, can we improve the yield, and can we improve the process. And I'll just look through various different areas here. So typically the steel comes from this area. It goes into a rolling process where they're making steel down here. And then when they're finishing it, this is areas where it's closer to the customer, because now we're looking at, okay, can we actually, predict some of the quality of the product? And if we can predict the quality of the product, can we do something about that? Can we rework it so the customer doesn't get defective product? Typically what they do today is they have to, if they want to improve the quality, they have to actually go out and do lab sampling, or they have to cut parts of the steel out, and it's very expensive to do that. They have to cut it in half and have a look at it to see what all the properties are. And these are just sort of other areas where we might work at a steel company. This is an example I gave you where this one is really us trying to keep the energy between us, or actually what we're doing is we're actually predicting or recommending the amount of energy that gets applied to a process. I think what's interesting about this particular example is that we actually started out trying to predict the amount of silicon that's in the steel, and we ended up actually just providing recommendations on the amount of energy to keep the steel between two different lines. And that was because it became very difficult to predict the amount of silicon in the steel 4 hours out. And so we just found it was much easier to try and keep the as we kind of talked about here before, try and keep the level of silicon in this close range just by recommending the amount of energy that's being applied. Okay, this is another one where we talk about these are called slabs. So they pour steel out here, and sorry, get things here. Oop. This is where they actually pour the molten metal in here, and then it comes out. This is called a casting process. And what we're doing is we're providing recommendation. They pour this out here, and then they can speed it up or slow it down. And what that'll do is that'll change the width of this slab. And they want it to keep it in a certain range because that's what the customer's looking for. So we actually are making predictions as the steel is coming down here and telling them whether they should speed up or slow down the casting process so it keeps the steel within a certain range. This one again is an example where we're using data as opposed to lab sampling. So we call this soft censoring. It's the really going out and looking at a particular process. This one's actually steel, and we're looking at the properties of it. We're making predictions as to whether the steel is falling within the specifications that the customer wants it to. And if not, rather than then have them having produced 10 coils of steel, we can tell them coil by coil whether whether they need to adjust their manufacturing process. This is an example where we're optimizing boilers. And so they may have two boilers that could be very similar, but a human being is deciding, which boiler to use and by how much. Whereas what we're doing is we're taking machine learning and we're providing recommendations on which boiler to use, when, how much, that kind of thing. And sometimes, like as an example, in a steel factory, they have a secondary fuel option. It's called coke gas, and they can use that instead of using natural gas, so they can reduce the amount of greenhouse gases that they're emitting. Very quickly, what we do, how we work, is we typically start with a customer. We look at their data. We do some initial data analysis, and then we start to train them on our platform. We start to onboard them. We give them examples of use cases like I've given you, only we give them a whole lot more. And we're teaching them really how to find opportunities within their business. Then we start to deploy the platform. We start to take their data in. We may have built some rudimentary models. Oops, sorry about that. We have built some rudimentary models, and now we're starting to do some live streaming data in the platform. We're starting to do some visualization, some monitoring, and then we deploy them into production. And then once we've done that then we try and do it across the whole enterprise. So we look at multiple facilities, multiple process, multiple assets, and we try and get the customer to deploy AI at scale. And that's really the end of the presentation for me.
Lou has asked, is this predictive preventative maintenance? Is it running in real time?
Yes, absolutely. That's the whole point. That's the challenging part, right? You can build off, you can use models using historical or offline data, and that's great to prove a point. But then, what do you do with it? And so that was always one of the biggest challenges when we got started. Is that it was easy for us to build these models, but then the customer say, "Great, now what do we do with this?" And so putting it into production, that's really hard work actually, and you need some kind of a platform to be able to do that. Otherwise, what happens is you build all these great models and they just sit on the shelf and nobody uses them. So this is actually using AI and machine learning in production and doing it at scale.
Awesome. Thank you, Lou. Thank you. We'll jump to the next question here. Somebody has asked, is your solution leveraging services from Azure Cognitive Services, or do you plan to? I'd be curious if you attempt to directly monetize the insight or automation on your SaaS product provides. So the question was essentially, is your solution leveraging services from Azure Cognitive Services, or do you plan to do so?
I'm sorry, I can't answer that question. I'd have to get someone more technical than myself to answer that question.
Okay, another question from Jose. He said, we have a client with lots of maintenance issues in a Cogent plant. Is this platform easily adjusted to their process?
Yes. I would say adjusted to their process. What I would say is that it can do a very good job of analyzing the process and provide recommendations or models that can help them improve the operation. So the example that I gave you in the steel company, where they have a couple of different boilers, we've actually used that as in a number of different cases where they have cogens, right? And they're generating, they're looking at a demand for steam and energy in a plant. But they have humans that are actually turning the dials to decide how much energy to apply to those cogens, whereas machine learning can actually do that, much better because it's using data to do it. And in that situation, and in the food plant, that one of the food plant examples is they're actually doing it with something called the closed loop system, meaning they're feeding us live data. We're doing a prediction, sending it back out to them. They've written a bit of code to pick that up and change the process control system so that they actually adjust that boiler automatically. Humans don't actually get involved in that process at all. So the machine, the cogens are actually being run by the recommendations of our AI model.
Nice one. Yeah, detailed response there for you there. Lou has asked, do you apply your analytics to areas other than manufacturing?
Industrial space only, but we do not. We don't do financial services. We don't do retail. It's time series data only right now. So hence the reason why we're focused mainly on industrial applications, because a lot of that data is time series based.
Nice one. Curious, just to kind of jump in there as well. I can obviously with various nuclear power stations around, and obviously Chernobyl as and other kind of nuclear meltdown type situations. Canvas analytics and kind of that space, is that something you kind of have made a foray into, or like you said, is it more kind of for that industrial manufacturing?
Yeah, mostly industrial manufacturing. Although we do work with energy companies as well. It's
Mm-hmm.
really just optimizing, the amount of energy that they use to produce energy.
Mm-hmm.
We've done a couple of different cases like that. And also, I should mention, when you're talking about places like nuclear plant, people are a little bit worried about, oh my gosh, is the computer gonna,
Yeah.
go haywire and blow up, half of Toronto?
Yeah, really.
That doesn't happen even if we automate it, because they have something called a process control system, which basically controls that whatever that is, whether it's a boiler or a nuclear plant, and it's based on the idea that a human could go rogue as well, and they could do all kinds of crazy things, but the process control systems limits what changes they can make. So even if we were feeding back those predictions, and for some reason, the program went haywire, there still would be a safety net in there.
Nice one. Lewis asked again, what types of cost savings are you seeing with the applications of machine learning and data science in manufacturing?
Good question. Really good question. And the answer is that it really varies a lot. If you look at like some processes, if you save 1 or 2%, it's a huge number, right? In other cases, you need to save 20 or 30%, to make it worth your while. So, I mean, I'd really have to go through use case by use case. It's also one of the areas that becomes very complex to give a specific ROI on it, because in the case of steel manufacturing, as an example, there's a whole lot of variables that are involved in it, and it's sometimes very difficult to narrow it down to just machine learning or AI. And the reason could be very simple. It could be something like they change their supplier of iron ore that they're putting into the blast furnace. So if the machine learning algorithm improves the process 10%, or it's 10% less the following month, is it because of all the stuff that the machine learning algorithm has done, or is it because they changed the Coke supplier? So sometimes it gets pretty difficult, but I think generally most customers understand the idea that if you're using data to make decisions, it's much better than humans. Like example in the steel company is what they always tell me is that what happens is that the first there's the guy who comes, the shift changes, and the operator comes onto the shift, and he's been there for 20 years and he's done the same thing over, and he knows the system very well. And he looks at what the guy before him, how he's got it all set up, and he goes, well, I don't actually like it that way. So he turns the knobs, right? And he changes it. And what happens is the process now starts to fluctuate. And while it's fluctuating, it's costing money because they're using more energy, and the product quality is going down because it's now very inconsistent, right? And then the next guy comes in and he does the same thing. He changes those dials, and the process goes like this. So one of the big advantages of AI and machine learning is that it takes the decision making away from the operator, and makes decisions or recommendations based on data, which is very reliable.
Yeah, I agree. I think well, it's all in the data. Somebody said recently that the data is the hottest commodity in the world at the moment.
Mm-hmm.
So I think in the right hands, yes, certainly. What kind of manufacturing could benefit from this most? Is it hard for humans to control themselves in real time? That could be done by a sensor and monitoring and controlling with ML.
So sorry, can you give that to me again? Maybe just break those down.
Yeah, sure. So what kind of manufacturing could benefit from this most?
I would say the big opportunities are in situation, like processes, right? Where there's a lot of expensive raw materials that are going into a process. So as an example, in steel, the biggest cost is energy, the natural gas, right? Because they got to heat this blast furnace up, to a tremendous temperature. And so whatever they can do to save 1% of natural gas is a big number to them. In other processes, it's different. If they're, it depends on what they're trying to control. And also, sometimes the ROI, the actual savings may not be as important as improving the quality of the product, because it's hard to value, so if you're doing a more consistent, better product to customers, what's that worth? So I think, the answer is probably all industries can benefit from it, but there will be varying degrees of return on investment based on the margins of that business and the cost of the inputs. I hope that's helpful.
Yeah, no, so that was a good response to a good question. Yang has asked, for most of the clients you have interacted with, do you see more deep learning models or traditional interpretable machine learning statistical models being put into productions to provide real-time business values?
That's probably a better question for the data scientists. The data scientists report to me. I think that what we found is that for the simpler problems, we don't need deep learning models, but for the more complex ones, we do. And so, like the whole idea is that what we do is that we take data and we put them through these pipelines that have a library of algorithms, and then it actually tells us, which is the best model. And the best model may not necessarily be the one that is the most accurate, maybe the one that tells us the most about the data. So sometimes just like simple linear models actually tell you more about the data, and that's actually more valuable than getting a really good result from a neural net, but you don't know why, right? So sometimes just learning about your data and understanding your data is more important than the actual result at the beginning.
Way to go. And our last question for you this evening, John, will be from Lou again. He asks, are you seeing manufacturers adopting AI technologies quickly?
Quickly is, I guess that's a word that's left up for interpretation. I think there's more and more interest of it. There's a lot of buzz out there about what it actually is, how it works, I would say the two biggest problems that we faced over the time I've been there is, I think the number one problem is the customers don't really actually understand how to use, where to apply AI and machine learning. Because sometimes the problems, they go into it with a specific objective in mind, and that objective changes based on what they see in the data. And so sometimes it takes, sometimes it's a bit of a journey, right? Some of these models that we have in production today, they're sort of the fourth generation, and they've taken a bit of a twist and a turn in terms of how we got there. So I think that that definitely plays into it. Is that just looking at your data and understanding your manufacturing process from a data perspective is valuable, and it sometimes takes time for that, for that to work itself in terms of adoption. But we are seeing more and more customers use AI and machine learning. There's more and more interest in it, and that's why we want to put a software platform in the hands of our customers so that they're not, so like one of the big issues that in AI and machine learning was the cost of actually, getting into it, right? Hiring consultants. And it's not that consultants are bad or evil or anything like that. It's just that when a consultant has to learn about a customer's business, when they have to learn about how to make steel, it can be fairly time consuming to do that. And meanwhile, the clock is ticking. So the idea is that, and what we believe is that the best person to build those models is the process engineer or the maintenance manager, continuous improvement folks. But unfortunately, they don't know data science. And so our goal as a software company is to take data science and make it easy for them to do. And we do that by putting, a very easy to use interface on the platform. And then if the customer needs some help with the data scientists, we do have people that, can step in and help with the solution architecture. But for the most part, we want customers to take that journey, the AI machine learning journey, a long way before we actually step in and help them out.